Hello friends, welcome back. In this tutorial, we will study about optimal page replacement algorithm. This page replacement algorithm has the lowest fault rate of all algorithms. And this algorithm never suffers from Bilaty's anomaly. So what happens in this algorithm? In this algorithm, we replace that page that will not be used for the longest period of time. It will be clear after this example how this algorithm works. Let us see how this page replacement algorithm works. Right now, let us see how this optimal page replacement algorithm works. Now consider this reference string, right? And in main memory, consider that we are having 3 frames. Initially all the 3 frames are free, right? So you can see that the first reference is to page number 7. So since initially all the frames are free, we are not having this page number 7 in main memory, so there will be a page fault, right? And this page number 7 will be brought in main memory, right? So it will be stored in a frame because we are having this free frames in main memory. Now the next reference is to page number 0, and now you can see that page number 0 is not in main memory, so there will be a page fault, right? So again this page number 0 will be brought in main memory. It will be stored in a frame, right, because we are having free frame. Now the next reference is to page number 1. So you can see that in main memory page number 1 is not available, so again there will be a page fault, and this page number 1 will be brought in main memory, so it can store in this frame because one frame is free here, right, in main memory. Now see the next reference is to page number 2. Now page number 2 is not in main memory, so therefore there will be a page fault. Now here you can see that main memory is not free. All the 3 frames are occupied, right? In main memory there is no space for page number 2, so one of the page which is in main memory has to be replaced. Then which of the page should be replaced? There are 3 pages, 7, 0, 1. Page number 7, page number 0 and page number 1. Then which page among these 3 pages has to be replaced? Then according to optimal page replacement algorithm, we have to replace that page that will not be used for the longest period of time, right? So in this reference string, we will check which page will not be used for the longest period of time. See the page number 0, right? You can see after this reference, the next reference is to page number 0, right? Now see this page number 1. For in a reference string, you can see 1, 2, 3, 4, 5, 6, 7. Right, in reference string you can see that after 9 references the page number 1 will be required, right? 10th reference it will be to the page number 1, right? Now see the page number 7. For page number 7 you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right, after 13 references page number 7 will be required, right? So here by analyzing this reference string, you can see that the page number 7 will not be used for the longest period of time among these 3 pages, right? Among these 3 pages, page number 7, page number 0 and page number 1, right? The page number 7 will not be used for longest period of time, so we will replace this page number 7, right? So here we have replaced the page number 7, and this page number 2 has been brought in main memory. Now in main memory we are having these 3 pages, page number 2, page number 0 and page number 1. Now the next reference is to page number 0, right? So here you can see that page number 0 is available in main memory, so there will be no page fault. Now the next reference is to page number 3, right? So here you can see that page number 3 is not in main memory, right? So there will be a page fault. So this page number 3 has to be brought in main memory, but there is no free frame available in main memory, so one page has to be replaced. So here we are having three pages, page number 2, page number 0 and page number 1. So which of the page should be replaced? Then again, according to optimal page replacement algorithm, we will replace that page which will not be used for the longest period of time. So here see this page number 0, the next reference is to page number 0, right? And see this page number 1. This page number 1 will be used after 7 references. This page number 1 will be used after 7 references. And now see this page number 2. Right, in reference string you can see that this page number 2 will be used after 2 references, right, from here. So among these 3 pages, this page number 1 is that page that will not be used for the longest period of time. So we will replace this page number 1 and we will brought in page number 3 in the main memory. So in this way, this optimal page replacement algorithm works, right? And this page replacement algorithm never suffers from Biletti's anomaly, and it has the lowest fault rate of all algorithms. Now what is the disadvantage of this optimal page replacement algorithm? The disadvantage of this optimal page replacement algorithm is it is difficult to implement because it requires future knowledge of the reference string.